All right, guys. So today is the first real lesson with chapter 1. Now, we did the vocab sheet yesterday, and again, I do the vocab sheet so y'all can kind of get familiar with the vocabulary terms, because most of the other math classes that you'll cover in here, Algebra 1, Geometry, Algebra 2, really doesn't hinge so much on the terms themselves, understanding what a line is, or what a ray is, or what degrees, angles, collinear, coplanar. We need to know what they are, because especially come homework or doing it, it's going to just ask what are the coplanar points. But we need to know what coplanar means, and we need to know what collinear means. So it's helpful to have those. Now, before we go delving straight into it, I want to talk about geometry as a whole. And what we cover in here isn't everything that there is. The professor that I had in college when I took calculus 1, 2, 3, 4, they split it up into 4 semesters, but essentially in most colleges it'd be Calc 1, 2, and 3. So it's essentially 3 semesters or a year and a half college-wise, which would be 3 credits for high school. In the overall scheme of things, he said everything we would learn in that class would be the equivalent of a drop of water in the ocean. It's not a lot. There's tons of math. There's so much that we can learn. So I decided to show you some of this here. Euclidean geometry is what we will cover. We'll cover some of this here. And I'm going to go on and hit the light so that you can see this a little bit better. I am getting some light dimmers eventually, so it won't be as bright. So these here are all of the different, or some of the different types of mathematics in Euclidean geometry. Now, they're not that big to read, that's fine. But these are some of them. And we also have all of these here. Well, and we won't cover a lot of this here. We'll cover some of it, polygons. Won't do too much with 3-dimensionals or nth dimensionals kind of geometry. We can talk about pyramids. And then all of this here is what we consider Euclidean geometry. Now there's also such mathematics that do not follow Euclidean geometry, and we call those non-Euclidean geometries, or non-Euclidean. And it's mainly non-Euclidean is dealing with the fact that given a point and a line, there's exactly one line that will be parallel through that point in more or less terms. So if I had a line and a point, according to Euclidean geometry, there's only one line I can draw through that point that will be parallel to the given line. Non-Euclidean geometry kind of breaks this rule. It doesn't follow it. And then we have other types of geometry that follow kind of more of a different line. So all of these here are some of the different types of math that there are, but we're mainly going to focus on Euclidean geometry. We're not going to focus into other types. Now, kind of delving into this here, our first thing on the notes is a point. And I'll turn the lights on so you guys can actually see. A point has no dimensions. A dot represents a point. It is essentially a location. A point is a location. And it is considered one of the undefined terms. And probably when you were doing the vocab yesterday, you noticed that it did say undefined, one of the undefined, a undefined term. These 3 here are considered to be the 3 undefined terms. And most of y'all did put the example down where it had a point and then A. Yes, you created a point A. Yes. But by definition, a point has what? No dimensions, yes? So it means it does not have a length, it does not have a width, it does not have a height. But wait a minute, when I drew the point for point A, this now has dimensions, doesn't it? I can take a ruler and measure it. It actually has a length and width. So is there any way for me to actually create a point? Well, no, because as soon as I put pen to paper, I give it a length and a width. So I can create points, but the point would not follow this definition of having no dimensions. That is why they consider this to be an undefined term, because we can't actually create a point, because once we do, we give it dimensions. So it's more of a figment for us to think about a point as a location more than an actual, because once we actually create one, it has dimensions. So it's a way for us to represent it as a dot, but we can't actually create the actual point. It's more of a mental construct. The next one we have is a line. Now you don't have to have this entire definition, because that is a lot to write. Because what is a line? A line has one dimension, and it is represented with a line by a line with two arrowheads and extends without end. A line has what? One dimension and extends without end. Without end. Through any 2 points, there's exactly one line. You can use any 2 points on a line to name it. And that is key.
Teachers, please be sure and put in your students who are not here. Please double check and make sure you put in all your absences.
So, through any 2 points, we can make a line. Now, any 2 points on a line, we can use to name the line. So for this here, we have, if I were to name it, we can name it line AB or BA. Order doesn't matter with naming lines. Now, I will tell you this right now. If you do not include the line that I drew above it, that you see above it, I will count off. Because what this does, having the line above it, is it's saying that this is line AB. What I'm talking about is a line. And they do this in mathematics so that if you're writing a paper or doing research or working with lines and whatever you're doing, and someone else came along behind you, didn't get to see fully what you were doing, they could read it and be able to say, okay, you're talking about a line. Because of the line above it, I know that AB is talking about a line, not a ray, not a line segment, but a line. So it helps us define what we're talking about. Because we'll be talking about different measures, because a ray and a segment still use 2 letters, so we need a way to differentiate between the two. And we can also call it line L, because at the very top it does have a lowercase l. If there is a lowercase l at either of the arrows, we can use it to name it also. Because if we're using that, the one letter, the lowercase, we just say line and then that letter. The capital letters are normally used for points. Capital letters are going to be used for points or locations. Lines themselves, we'll use lowercase. So any questions on point or line? Now, actually, as I say that, line, again, undefined term. The reason they talk about this is because, again, we can't really fully draw a line. Because what do we say about a line? 2 arrowheads and it, what? Extends without end. So no matter how long I drew this line, there would still be more of it. I could never fully draw a line. So we can't really make a line. So again, this is another mental concept that we understand, that because of the arrows, it extends without end. No matter how long we make it, it's still going to go on. And the third one is a plane. Now there is a lot here you do again. You do not have to write this entire definition now, because one, you got them down yesterday. So you can write it down again if you want. But when we look at this here, a plane has 2 dimensions. It represents It is represented by a shape that looks like a floor or wall, but it extends without end. Through any 3 points not on the same line, there is exactly one plane. You can use 3 points that are not all on the same line to name a plane. So it's a two-dimensional plane. It almost looks like a rectangle, or we can picture it as a rectangle or a piece of paper. It is a flat surface. But again, just like with the line, this extends without end. So there's no way to fully draw it. Now we'll create planes by signifying it with a square or a rectangle or a four-sided figure, like they did here, to show it. Now the way we name it is pretty much just plain ABC. 3 letters that are not on the same line. And that's key to remember, not on the same line. Because if it happens on the test, might be on the homework or the review, if there is a line with 3 points, you cannot use those 3 points to name it. You can use 2 of the points on the line and 1 point that is not on the line. That's fine. But if all 3 points are on the line, it does not work. We need 2 points that can be on it and 1 not. Because essentially behind what they're saying is really from a mental standpoint. So think of a line in your head. So you got a picture of a line? Now take that line and stretch it out. Expand it down. And as you think about expanding it, you're creating a piece of paper essentially, yes? That is essentially what we have here. So if we wanted to define it, we couldn't use a line because a line's just a straight line. We needed something to give it width. We needed another dimension. So any questions about these 3 definitions so far, 3 things we've covered so far? Okay, so we're good with point, line, and plane. So naming plane, plane ABC, 3 letters, not on the line. Now if you notice point M doesn't have a point with it, yes? Because M, there's no location with it. That is naming the plane itself. This whole plane, we can name it plane M. If the letter is not close to a point, it's naming the plane. Now, it might be naming one of the edges. This here, the vertex. But if that's the case, it's actually, this here is not. It's actually classified by the plane. If on a test or something else you're just curious, just making sure, is this attached to a point or a plane, ask. I will clarify that on a test. That is fine. You can ask me that on a test. I'm not going to give you the runaround or not say. I will specifically say, okay, M is attached to this or whatnot. So if you ask A is this point, B is this point, C is this point, I will show you. So that way if there is any confusion, I will clear that up. Okay? Now there is one other definition on here. So planar and collinear. Now, these definitions here are not actually that bad. Coplanar and collinear. I think you have collinear. Either one, whichever one you're on right first. Collinear. Linear means line. Collinear means on the same line. Coplanar, plane on the same plane. So points that lie on the same plane are considered to be coplanar. Points that lie on the same line are considered to be collinear. Collinear, points on the same line. Coplanar, points on the same plane. Not bad definition so far. And we've seen those, you guys have seen all these definitions already from the vocab sheet, yes? Awesome. Okay. Let's look at the first example. give two names for, it should be line PQ and plane R. So PQ is this line right here. So, well, we can't use PQ, but we could use what? Line N, yes. So we could say line N, because it gave us the little n up top, so we can use it to name the line. Now we need one other way. QP. Now, if there was another letter on that line, another point on that line, we could use it as well. Because the points that we use for a line do not matter. Because again, a line extends without end. So no matter what 2 points I use on a line, it'll cover any other point that's on that line, because it'll extend without end. And we'll see some in a little bit that it doesn't work that way. Okay, well, we also need 2 more names for plane R. So, plane what? Okay. Almost, yeah, well, V is a point. So we need 3 letters, TP. Plane. That is the one we actually cannot use, because SPT lie on the same line. Where is it? SP what? Yeah, SPV. Because we could be STV, PTV, VTP. Any combination of those 3 letters will work. The only ones that don't work, well, there's 2, is SPT, because that won't work, or any of them that include what point? There's Q, because Q does not lie on the plane. Q is considered to be above the plane, which that seems weird, doesn't it? How can something be above the plane? Well, essentially, it's the same as if we consider this floor, the plane extending without end. My hand is technically above it. Because if we think of it as a flat surface, anything above or below would not be contained in the plane. And if we went to a higher, went a little bit beyond anything we'd cover in here, we can technically consider our 3-dimensional, or 4 if you consider time, to be a plane of existence. So if someone existed on the 5th dimension, it would be outside of our plane. Hopefully I didn't, a little bit of a mind mess there, but we'll move on. Name 3 points that are collinear. SPT. SPT. Because again, collinear means that they're on the same line. Coplanar points. V. Well, we can't use R because R is naming the whole plane. S, P, and T. Because all 4 of these are the coplanar points. They're all on the same plane. The only reason we can't include Q is because, well, Q is not on the plane. Any questions on this here? Okay. Use the diagram. In example 1, well, I provided it again. Give 2 other names for ST, line ST. We'll do it. Yes. Okay. Okay. I can think of two more, TP and PT. Anything else we need to do? Some of y'all remembered it, because I intentionally, yes. I intentionally left that out to see if anybody would catch it. But we have to have the line above each one. Because when we're naming a line, we need the symbol for line. Because I will count off on that on the test. I do give points for naming it and using the correct symbols. And we could do it in any one of these ways. The last way is line him, because they gave us the letter. Now, one of the interesting things with this, on a side note, is that line TS, PS, SP, TP, PT, or line M is contained within the plane. Because if you notice, both of the arrows do not extend outside the plane. A line extends without end. A plane extends without end. So this line is always going to be contained within the plane. Now, the only way we know for sure that it doesn't is like this one here. We see that it intersects the plane and leaves. So it does not stay in the plane. It only makes impact at one point. Okay. Now there is a second part to this question. Name a point that is not coplanar with Q, S, and T. So it would be V. Because if we think about this plane, I'll draw it in here, it is going straight up and down. It's not pictured in it because it's very tempting, because until I read it, I was like, okay, this is going to be easy. It's going to be Q because it's not on the plane, but it didn't actually picture it. So what we have is this here, and V is outside of it. We essentially created a plane going straight up and down. Questions on this here? So our non-coplanar is point V. That would be the non-coplanar point. Yes. Do you have a question? Okay. Are we good with all of this here so far? Okay. Now, there are other types of line segments that we'll talk about. One of them is actually called a segment. There is a lot here. Do not write all of this. Do not write all of that. There's no point in writing the whole thing. So what I'd have you write instead of this, don't write this, because this is the mathematical technical jargon. Because a line segment AB, or segment AB, written as AB with this line segment, because it has two endpoints, consists of the endpoints A and B and all points AB that are between A and B. Note that segment AB can also be written as BA. Well, a line segment is a line with what? Two endpoints. A line with two endpoints. That is all that is saying. So really a segment, a line segment, is a line with two endpoints. Now this here has a limited number of ways that we could write it, less than a line. Because even if I create a point C here in the middle, well, segment AC is not the same as AB. because again, it has two endpoints. AC is only going from A to C. It's not ever going to reach B. Because the fact that it has two endpoints, AC and AB are not the same. The only way we can name it is using the endpoints. So it's either AB or BA, one of the two. Does that make sense? Again, with Ray, there's a lot going on here. A ray, I'll simplify that down for y'all, is a line with one endpoint. The ray AB, written as AB, consists of the endpoint A and all the points on AB that lie on the same side of A as B. So it's a line with one point and extends off in the other direction infinitely. That's all a ray is. That's also kind of why we call them light rays, because from the sun, light rays from the sun have a starting point at the sun and then extend off in one direction indefinitely. Well, they would extend in the same direction if there was no other gravitational forces and other things affecting it, because it will get affected. Light rays, when they approach large gravitational bodies, will get bent, and other such factors. As on a side note, as you will learn throughout the rest of the semester, and if you haven't had me before, my humor is very dry. I have had a friend in college who was sick of them after week 1. His name was Ray, and the number of Ray jokes that I made was a lot. Come around Christmas time, we were helping set up a tree in the dormitory, and he was up there pulling the rope. I told him, hey, Ray, don't go too far. You can't come back. It only goes in one direction. But at another one, we talked about rays. Light rays will bend when they get towards large gravitational pulls. Saw him one day, I'm like, hey, Ray, feeling all right? You look a little bent. Too close to Earth. By the end of it, he would laugh for 2 seconds and then get super frustrated with me. So you'll get to hear more of my dry humor throughout the semester, and if you don't laugh, that is fine. My wife does not either. Now, opposite rays are two rays that go in, what would we guess, opposite directions that share a common endpoint. Wait a minute, what does that look like? A line. Opposite rays make a line. I'm going to make one more note with rays about how we write them here in a minute. Okay. Now, when we write the name of a ray, or when we name a ray, the common way and what we'll use is that the endpoint always starts. The endpoint is always going to start. So when we look at these two here, this first ray, well, the endpoint is A, and it goes through B. We start at A and we go through B. For ray BA, even though the ray is going the other way, where does it start? We start at B and go through A. We want to use it this way. It is not common practice for, say, the first one here to go BA and draw the arrow going to the left. I do not know who decided this kind of standard, but that is what we use. So we won't use that. We'll stick with these kind of here, using those ways to write it. Any questions on this here? All right. again, we'll look at some examples. Okay. Give another name for GH. Another name for GH would be HG. And that's it, because with segments, we only have the two ways to name it, HG and GH. Name all rays with endpoint J. So J, E, J, G, JH, and JF. I set them up that way because I put them in the pairs that are opposite to make a straight line. JE and JF do make a straight line, so they are opposite rays. JH and JG are two rays that make a straight line. Questions on this here? Are we good with this here so far? Yes? Awesome. So we'll finish up with this here. We'll have to finish these tomorrow. Give another name for KL. Okay, and we have our line segment above it. RKP and PK, the same ray. So we'll finish, let's finish this up right here. I'll write a note if you need. So I just want to finish on this here. What would you guys say? Are KP and PK the same ray? Because again, we go endpoint and extend. They have different endpoints. So KP is this here. PK is that one. We'll stop there. Y'all can go on and go. We'll finish this tomorrow, and we'll probably start the next lesson. We'll see where we get.